I'm gonna solve the problem 11.10, which is a man climbing a ladder against of a frictionless wall. What do we know? We know the weight of the ladder, the weight of the man, the coefficient of the static friction. These are given by the problem. The equations that we're gonna use, it's the static equilibrium, which is all the summations of forces on x and y are equal to 0, and all the summation of torques are equal to 0. Notice that I choose the axis of rotation for torque, this point B, and all the torques are gonna be calculated on this point B. So for the first part of the problem are asking us to solve for the maximum friction over here on this point. For that I put a free body diagram of all the forces. We have the friction force over here, the normal force on this point B. We have the weight of the man, the weight of the ladder, and the normal force over here. So using this Newton's second law, we're gonna solve for friction. So we have the summation of all the forces in the y direction equals to 0, and then in the y direction we have the normal force on B minus the weight of the man minus the weight of the ladder are equal to 0, which is giving you that the normal force on B is going to be equal to the weight of the ladder plus the weight of the man, which is equal to 160 newtons plus 740 newtons, and this is equal to 900 newtons. For formula, we know that static friction is equal to the coefficient of friction times the normal force, in this case a normal force on B, which is equal to 0.40 times 900, and this is equal to 360 newtons. And we know that this friction is maximum because at this point this friction is holding the ladder in place. Now for part B, we are asking to find the friction force when the men have climbed 1 meter, when this is over here 1 meter. And for that, we're gonna have to find these distances, this distance A and this distance B. For find the distances, we need to find this angle and the height of this height h. So for h, we know that this side of the triangle is 3 and this is 5, so h is going to be equal to the square root of 25 minus 9, which is equal to square root of 16, and h is equal to 4 meters. And for theta, we know the inverse cosine of theta is equal to 3 over 5, which is going to give us a value of theta of 53.13 degrees. So now we are ready to find the distance A, which is going to be equal to 1 meter times cosine of 53.13, and this is equal to 0.600, and the distance B is going to be equal to 2.5 times the cosine of 53.13, and this is equal to 1.500 meters. And then we're gonna use the summation of torques on point B equals to 0, which is going to be equal to the torque, which is the weight of the man is doing a negative torque. So it's going to be negative the weight of the man times the distance A, which is the perpendicular distance to the torque on point B. So, and minus the weight of the ladder is giving a negative torque as well. That's what is negative over here. So it's the weight of the ladder times B plus the normal force over here times the distance to the perpendicular distance to the point B, is going to be normal times h, and this is equal to 0. So solving, and normal force is going to be equal to 740 times 0,600 plus 160 times 1.500, everything divided by 4, and this is equal to 171 newtons. And we know that the summation of forces on x is going to be equal 0, and the forces are the friction minus a normal force on A and equals to 0, which is giving us that the normal force on A is equal as the friction, and friction is equal to 171 newtons, which is the answer to the part B. Thanks. Okay, for part C, we're gonna find this x. Let x be the maximum distance that the mic can climb on the ladder before this one starts slipping off the wall. So let's find this distance x over here. Okay, so for that we're gonna use the same last formula, which is the summation of torques on B equals to 0, and we know from the last step that this is equal to minus the weight of the man times the distance A minus the weight of the ladder times the distance B plus normal force on A times H equals to 0. But this time we have to find this A, and solving for A, we get this. A is equal to normal force on A times H minus the weight of the letter times distance B over the weight of the man. But A is no more 1 meter like in the last step. We have to find that distance, and this is going to be x times cosine of theta. So x is going to be equal to normal force on A times height or H minus the weight of the letter times distance B over the weight of the man times cosine of theta. So, and this is going to be equal to x is going to be the coefficient of static friction times the weight of the man plus the weight of the letter times H minus the weight of the letter times distance B over the weight of the man times cosine theta, and put it all together. We have all the values. This is 0.40 times 740 plus 160 plus H, which is 4, minus 160 times the distance, which is 1.5. B is the same, 1.5. And then we have the weight of the man, which is 740 times cosine of 53.13 degrees. And this solving, putting all this together in the calculator, is equal to 2.7 meters, which is the last answer to this problem. Thank you.